So exercise on indices. This is exercise 1.3.2. In this exercise, we're going to use our components and the rule of indices. We know the three rules of indices. We know that AM times AN times AM will be AN plus M. We also know that AN divided by A to the power of M would be A to the power of N minus M. And the third one, which is straightforward, would be AM to the power of N would be AMN. So those are the rules of indices that we're going to be using. So these are the three rules. So that's the one rule, 3, 2. Those are the rules of indices that we're going to use. But these are the 5 components. Component 1. So that's component 1, component 2, component 3, component 4, component 5. Now let's do the first question. So we're going to be using that for question 1. So we're going to be using this one, rule number 3. And that will give us, now this is 4, there's 1 here, because A to power A is A to power of 1. So there's 1 here. If there's no number, it means there's 1. So you do 4 times 1, so A to power 4, and 4 times 2, A to power B to power of 8. And that will give us A to power 4, B to power of 8. That's it. Question number 2, we're going to be using that one here, that component here. You see A is 2 and N is 3. So you'll be saying 1 over 2 to the power of 3, which is what that is. And 2 to the power of 3 is 1 over 8. Because 2 to the power of 3 is 8. 2 times 2 is 4, times 2 is 8. So that's the answer. Now we got question 3. In fact, 3a. We're told to find the value of x. This is 4 to the power of x and equals 3 square root 16, cube root 16. Well, there are a few ways we could do this. We could leave the 4 there and the power of x and change this format from there to this one here. So we could use number 4 for the cube root 16 and rewrite it like that. So component 4 is applicable here. I know that cube root 16 can be written as 16 to power 1/3. So that's what we've done here. So we can go back and forth when you're writing this one. So that's good. But I also know that 16 is equal to 4 squared. All right. So I could replace the 16 by 4 squared. So, which means I have 4 squared to power 1/3. So now I'm going to use the law of indices 3 here, because I can see that there, and so I just have to multiply the two powers together. So if I'm multiplying the two powers together, I will get 4 2 over 3. 4 to power 2 third. So I can now rewrite this as 4, right? That's the 2 there. 2 times 1 is 2, and then that's 2 over 3. So that would be 2 over 3. So 2 times 1 is 2, and that's 2 over 3. That's how you got 2 over 3 there. So that would be 4x to power 2 over 3. So what we've got now is they have the same base, and there's an equal sign between them. Because they have the same base, that means their power has to be equal. Therefore, x equals 2/3. Question 3b. 9 to the power of x equals 1/3. So I'm going to split the 9. 9 is 3 squared. So I could do 3 squared to the power of x equals, I could change the 1 over 3 here. You can see 1 over 3 here. This is 3 here and 3 to the power of 1. 3 to the power of 1. 3 to the power of 1 there. And you know that 3 itself, just this one here, a to the power of 1 equals a. So 3 actually is 3 to the power of 1. So I could rewrite this as 3 to the power of minus 1, because there's a 1 here. So 3 to the power of 1 becomes 3 to the power of minus 1. So that 1 over there. So there's a 1 here. So that's that. So that's how to rewrite that. And I could multiply the 2x together. So that would be 3 to the power of 2x equals 3 to the power of minus 1. Now you can see they have the same base. That means their power has to be equal. So let's just draw this line here so we have more room. They have the same base. Their power must be equal. So that means 2x must equal to minus 1. Same base. The power must be equal because there's an equal sign between them. And therefore I need to find x. So x will be equal to minus 1 over 2. So that's how you do that. That's question 3b. Question 3c. 16x, 16 to the power of x squared equals 1/4. We need to find x. Right. So the clue to these questions are to make them the same base. So if I could remember, 16 is also 4 squared, because 4 times 4 is 16. It's just 4 to the power of 1 times 4 to the power of 1 will be 4, 1 plus 1, which is 4 squared. We just apply indices there. So that's 1 there. 1 times 1. 1 plus 1, sorry. 1 plus 1. So that's how we get 4 squared. Now, so I can substitute 4 squared here. So that would be 4 squared times x squared equals 1/4. But if I use this rule, 1 over 4 here, 4 is to the power of 1, so there's a power of 1 here. And if I can rewrite that, that would become 4 to the power minus 1, which is that one here. 1. So if I put 4, 1 here, so that 1 it goes there. So 4 to the power minus 1. So that 1 is coming from here, power of 1. Now, and then I need to use this rule here. I'm multiplying 2x by 2. I have to multiply the 2x, n is 2x here, times it by 2. So that will be 4x. Now they have the same power. Now they have the same base and their power must be equal. So that means 4x must be equal to minus 1. And therefore x must be equal to 1 over 4. So x is minus a quarter. Question 3D. X to the power minus 3 equals minus 8. In this situation, I would want to rearrange this equation in order to find x, because we were meant to find x. So what I would like to do is say, well, 1 over x cubed. So I've used that one here. So I've used the component number 3, 3b, 3a, 3b, that one there. So that's minus 3, that's x, 1 over x cubed. And that will be equal to minus 8. So I could cross multiply. If I cross multiply, that becomes, I could say 1 over 8 equals minus x cubed. So all I did was multiply both sides by x cubed and divide both sides by 8. Or just swap them. You can swap them. So this is over 1, so that goes there, and that goes there. So we just swap them in this case because they're equal sign. Now, and I know that this is basically 1 over 2 to the power of 3, which is minus x to the power of 3. Now, if I take the 3 out completely, if I take the power of 3 out completely here, I will get, for instance, 1 over 3 to the power 2 over 3 is the same thing as 1 over 2 taking the 3 out. So it's the same thing. So that this one here is the same thing as that. So because 1 to the power 3 is 1, and that equals minus x cubed. Then now I can see that they both have the same power of 3. That means the base must be equal. That means that a half, which is the base, is equal to minus x. Therefore, x will be equal to minus a half. So I hope that is clear. So all I did was swap this around and leave the minus. So I had 1 over 8 equals minus x cubed. So that's what I did there. And then I basically changed because 8, we know that 8 equals 2 to the power of 3. So I replace that 8 by 2 to the power of 3. And I know that 1 to the power of 3 will give me 1. So I just make them the same. 1 over 2 to the power of 3. So I'll take the 3 power out, which equals minus x cubed. And because they have the same power, the bases must be the same. So the bases are half here. So a half equals minus 8. Therefore, a half equals minus x. Therefore, x equals minus a half. Question 3e. I got root of 5 times 5 to the power of x equals 1 over 25. Again, there's a clue in this question. The base has to be 5. So I'm going to make all of them the same base. Well, the root is that one here. So remember that root of 5 can also be written as 2 root of 5, which is 5 to power a half. So that's 5 to the power of a half. And so I can replace this one by 5 to the power of a half times 5 to the power of x equals, now 1 over 25, well 25 is 5 squared, which is 5 times 5. So 25 is 5 squared. 5 times 5 is 25. And if you add 5 times 5 to the power 1, 1 plus 1 is 2. So that'll be 5 to the power of 1 times 5 to the power of 1. That'll become 5, 1 plus 1, which is 2. Okay. Now, but we got 1 over 5 squared. So I'm going to use that one here and transform that into that. So the 2 will become there and 5 here will be there. So that will become 5 to the power minus 2 and x plus a half. So that will be 5 a half plus x. Because they have the same base, their powers here will be equal because there's equal sign between them. So therefore, a half plus x equals minus 2, which means that I can take the minus a half to the other side. The sign will change. So x will become minus 2 minus a half. Well, x will then be minus 2 over 1 minus a half, which is the same thing. And what I can do is make this base 2 as well, denominator 2, and make the, so if I multiply that by 2, I have to multiply that by 2, so that'll be minus 4 over 2 minus a half. Because they have same base, I have minus 5 over 2. Because minus 4 minus 1 is minus 5 over 2. So that's what x is. X will be equal to minus 5 over 2. Now, question 3f. Now, there's a question, root of 100 to the power of x equals 0.001. Well, so we need to find x. So just to remind us again, 0.001 is 1 over 1,000, which is 1 over 10 to the power of 3, which is 10 to the power minus 3. So that's good. I have used 10 to the power, I've used that one, which is what I've done there. Now, so I can replace that with 10 to the power minus 3. Now also I know that 100 is 10 to the power of 2, and therefore 100x would be 10 to the power of 2 times x, so 2x. Or just put 10 to the power of 2 into bracket, and if I use the law of indices here, number 3, 2 times x is 2x, so that would be 10 to the power 2x. But then if I square root that 10 to the power of 2x, so square root of 10 to the power of 2x, which I'm using this one here, a is 10 to the power of 2x, and I'm square rooting it, so m is 2. So I would have 10 to the power of 2x to power a half, so that would be 10 to the power of 2x to power of a half. Again, I'm using this rule number 3 to multiply them, so I'm multiplying 2x times a half, so that's a times a half, which is 2x over 2. 2x over 2 is just x, so that's just x. So that will be 10 to the power of x, because the 2 will cancel 2. So I'll put here 10 to the power of x. Therefore, and I have same base, and the power must be equals. So therefore, x equals -3.